The link between your gamepad and your robot is one of the most critical parts of your entire control system. Getting this right from the beginning is key to building more complex and reliable robot programs later on. My name is Coach Pratt, and for over 10 years, I've been a robotics educator, and I've coached FTC teams to national championship wins and multiple Inspire Awards. I know exactly where the common pitfalls are when it comes to programming your controls. So in this video, I'm going to run you through exactly how the gamepad data gets exposed to your robot and what that even means. We'll connect to your gamepad, read the inputs from the joysticks, buttons, triggers, and then use some basic math operators to modify that data. We'll finish up with some practical exercises that you can be confident that what you know actually works and that it sticks around. Let's take a look at the gamepad. I'm using the Logitech G310, I believe, but you can also use PlayStation or Xbox controllers. They're both acceptable. The gamepad exposes several buttons, quite a few. Some of them it'll do as analog sensors, some of them it'll do as digital sensors. And we'll talk more about that as it goes, but basically some will give you a range of values and some will give you Booleans or true or false. All of the buttons will give you true or false, off or on, true, false. Whenever you press them, it goes true. Whenever you depress them, it goes false. The same is true of the D-pad. It'll give you 4 directions, left, up, right, and down, respectively. And it does the same thing. It's a digital sensor, up and down. Now there's also these 2 bumpers up at the top. These are similar to the buttons. They'll give you true or false values as well. Oh, you also have 2 more inputs, your start and your back button. And then on the Logitech G310, if you have it connected, you have to make sure you're on the X mode, then the D mode, or it won't be recognized properly. Now on the triggers at the back, these will give you an analog. They'll give you 1 if it's depressed all the way, and 0 if it's not depressed at all. That means that if you push it in just slightly, you'll get things like a half value or 0.75, something between 0 and 1. The same is true of the analog joysticks, that the analog joysticks actually have 2 analog axes. They have a Y-axis for up and down, and then an X-axis for left and right. Now, curiously enough, this is easier to draw it on a grid here. The Y-axis, it will go from 1 to -1. -1 when you push forward and 1 when you pull back. Whereas on the X-axis, it'll give you 1 or -1 on the left and +1 on the right. And then in the middle, it'll give you about 0, 0. Now, all of these various buttons, analog sensors, triggers get what's called exposed to your robot controller. So you are exposing these sensors to your robot controller. And let's take a look at what all the different points and what they're named and exposed as. Going back to Alan Smith's excellent book on Learn Java for FTC, you can take a look at all the different names that the controller will expose to your driver station. You have left_trigger, left_bumper, so on for the right side. You have start and back, D-pad_down, left, right, left_stick X, Y, and so on and so forth. A, B, X, and Y. You can also use the stick buttons for your right stick. Now, this is a new naming convention that shows up. Typically, sensors, it is not required, but sensors inside FTC are typically written in snake case. So there's a lot of different ways and conventions that we're going to be writing things. Sensors are typically snake case inside of FTC program. And that's more of an embedded hardware thing. That's not always the case. But for the FTC SDK, it'll show up like so. Today, we're actually going to go ahead and get into the loop section of this. So I'm going to come over to our Android Studio, and we're going to create a new class. And we're going to call this one Gamepad Practice. Again, classes are in Pascal case. They're capitals for all words. And in our public class Gamepad Practice, it's going to extend op mode, just like we did, extends op mode with capitals. Use tab to autocomplete your op mode. And then before we actually start writing our methods inside of our class, we also need to write at teleop. Now at this point, we have written methods in the initialization method. So we're going to go ahead and do that. We're going to say our public void initialize because our op mode always needs an initialize method and it needs a public void loop. So we're going to go ahead and put in a public void loop so that we can get rid of that error. But we're not actually going to write things inside of initialize because if you remember, the op mode or this loop, this runs roughly 50 times a second. And if we were to just write, we're going to get data from our gamepad. If we did this inside of our initialization statement, we would only ever do it once what the gamepad state is when I initialize the program. Instead, we want to always be getting the data from our gamepad. So let's actually go ahead and read that gamepad sensor inside of our code. So I'm going to go ahead and say telemetry.addData. I'm going to add in the literal string x, and then we're going to read the x value on our gamepad. So for the left joystick, we'll be able to read the x-axis as well as the y-axis for up-down. We are also going to read the A button and do that. So I have this telemetry add data. It's going to be x. I'm going to say gamepad. There are two gamepads that you can access because the driver station allows you to connect up to two different gamepads because it has 3 USB ports, Gamepad 1 and Gamepad 2. So inside our code, you're going to have to make sure you grab the correct gamepad. We're on Gamepad 1. We're going to press the period symbol. And this are all of the different data that we can grab. So you never have to worry about forgetting what am I looking for. In this case, we're going to grab gamepad.leftStickX. Put our semicolon to finish it. We're going to go and repeat this for our Y. If you want to try it by yourself, I would pause and see if you can figure out how to do the Y. Jump back in, we'll do telemetry.addData. We're going to put in the literal string y, put in a comma, and we're going to gamepad 1.leftStick_y with a semicolon at the back. And the last thing we're going to do is add that A button. So we're going to say telemetry.addData again. You're going to get really good at writing telemetry.addData. We're going to do the A button, put in a comma, and it's going to be gamepad. Oops, I put in a period there, not a comma, which is why it's not working. Gamepad 1.A, and then semicolon to finish that off. So if we look at our entire program, we have our import statements, we have our class, which is gamepad practice, we have an empty initialization statement, and our loop where we are effectively just going to add whatever reading is showing up on our controller. So let's go ahead and build this and install it over on our robot controller. So while we're waiting for this compile, we can actually have our driver station learn our gamepad. So we can grab our USB cable. I'm going to plug it into any of the ports you choose. I'm going to choose the far left one. And then because we have two gamepads, we need a way to tell it which gamepad is which. So in order to tell the gamepad, you're going to hold the start button and press A. You'll notice that it recognizes users 1. To be able to put in the second gamepad, you will hold start and press the B button respectively. So let's go ahead and run this program. So I'm going to select teleop, select the gamepad practice, and we'll do our init, which again is going to show nothing because we had an empty init method. Then we click play, we'll go inside our main loop where now you can see that X is 0, Y is 0, and the A button is currently reading false. So if I were to go around and start playing with some of these controls and I tap the A button, you'll notice that it is now switching to true and false. Whenever I tap it, it says true. And whenever I let go, it goes back to false. Now over on our joystick, you'll notice this gives us a range of values. So we can go up and down, left and right for our Y-axis and our X-axis respectively. So if I push it all the way up, I get -1. And as I pull it all the way down, I get up to +1. And when as I move slowly, reset it back to center, I get 0. And as I slowly move it through, we can see it's actually going to give us a range of scales between -1 and 1. Same is true on the X-axis. All the way to the left is -1. And then all the way to the right is +1. And then it gives me all those ranges in the middle as I slowly move back and forth between the two. We're going to switch gears a little bit here. Let's talk about using math and variables together inside of Java. Just like you use on your standard graphing calculator for math class, you can do the same thing inside of Java. You can add variables together with add and subtract. The multiplication is the asterisk symbol. Division is a single slash. You can use modulo, that'll give you a remainder using percentage. I think you can also use parentheses. So just like you would add in equations inside of a graphing calculator, you can do the same thing in Java. So let's go ahead and actually do that. You'll notice with our left stick, when we push forward, we get negative, and when we pull back, we get positive. Let's actually change that around to something that might feel a little more intuitive to you. Where you push forward, you get a positive value. You pull back, you get a negative value. Although when I say intuitive, it depends on where you are in the world as you're driving up or driving down. Some people may think of that as negative. Some people may think of that positive. So you feel free to keep it as you would, but we're going to go ahead and swap that direction just for a little bit of practice. So inside of our loop this time, we're actually going to go ahead and we're going to change that we're going to change that around. So we're going to create a new double variable, and we're going to call this one speed forward. And our speed forward is going to be equal to our gamepad 1 dot left stick Y with a semicolon. Now instead, we're going to go ahead and put in the negative symbol. So this is effectively going to flip whatever the current, if it's negative, it's going to multiply it by -1. If it's positive, it'll multiply by -1, and we will end up with the correct negative or positive values. We're also, just for a little bit of practice, get used to some of that math. So we're going to grab that negative left stick Y and divide it by 2. So we end up with half of the range. That was what we did before. So this might be useful for if you don't want to be able to drive at full power. You might only want to be able to drive at about half power. So once we've gone ahead and used our speed forward, we need to actually use our variable. So right now, previously, we just added the data with the gamepad left stick X. In this case, we're going to go ahead and remove this left stick X, and we're going to actually put in speed forward as a variable. So now if we run this over to our code, we should have our X joystick going between -1 and 1, and our Y joystick going between 0.5 positive down to -0.5. As we wait for that to compile on our robot controller, there are other types of math operators you can use. We'll get more into this later. Know that ++ is an increment, which will increment by 1. -= would increment something by -1. Plus equals would be the same thing as, this one's a little more confusing. X plus equals 2 is the same thing as X equals X plus 2. So you can put the symbol in front of it and just write a little bit shorthand. Programmers do like to write things shorthand because they tend to be quite lazy. We'll get more into that later. So let's go ahead and let's take a look at it. So I'm going to go ahead and open up the tail program, grab our gamepad practice. We'll run our init method. Again, nothing's going to happen, and then run our main loop. And now you'll see that our y-axis is now set to -5. And when I pull it all the way to the bottom, we're now getting -5. All the way to the top, I'm now getting +5. And let's go ahead and let's get into some practical exercises. Again, I highly suggest that you actually work through these practices and do them yourself. Don't just sit through and watch me program, because you're not going to learn. The first one I want you to do is I want you to add telemetry for the right joystick. You don't have to do any of the speed forward or anything like that, but I do want you to show and display that right joystick's X and Y axis. Pretty easy to do. We're going to say telemetry.add data. At this point, we're going to have to differentiate between our X's and Y's. You could say something like X2, or you might want to say right X. So you keep track of this. It's going to be gamepad 1 dot right stick X. We'll go ahead and do the same thing for telemetry.add data for right Y, gamepad 1 dot right stick Y. Add a semicolon at the end. And I would like to actually go ahead and change these to left X and left Y. Reason I do that is because otherwise you're going to get confused real quick as to what one you're actually doing. And I always like to be very clear when I'm programming. The second exercise, let's add telemetry for the B button on gamepad 1. Solution to this one's pretty simple. It's the exact same thing as our telemetry for A button. So we're going to say telemetry.add data. We'll say B button, comma, that's period. Gamepad 1 dot B and semicolon to finish that off. Now here's a fun one. We're going to have to actually do a little bit of math. So I want you to add telemetry data to report the difference between X on your left joystick, and X on your right joystick. So I want you to add telemetry data so that it shows the difference between the two. Now, one thing I want you to know is that in programming, there's 1,000 ways to skin a cat. There are a lot of ways of achieving the same solution. So I would like to write this as a variable so that I can keep track of this later. But if you wrote this in line on your telemetry, that's also okay. So I'm going to say and I'm going to say difference between the X joysticks is going to be equal to gamepad 1 dot left stick minus gamepad 1 dot right stick x. And this should return the difference between the two. Now we just have to add that data. So I'm going to go ahead and add this to all my joystick sections. So I'm going to say telemetry dot add data. And I'm going to add this difference in x, add a comma, and we're going to say the diff in joysticks x with a semicolon. The reason I want to do that is because it makes me read the joystick less. Now for exercise 4, I want you to add telemetry data to report the sum of both rear triggers. So add in the sum of both of those triggers together. Add that again, I'm going to go ahead and do it as a variable. So I'm going to say double sum of triggers is going to be equal to gamepad 1 dot left trigger plus gamepad 1 dot right trigger with a semicolon. We'll go ahead and add that telemetry down as a third line. We'll say telemetry dot add data. Sum of the triggers with our sum triggers variable, and close that off and add a parentheses. Sorry, add a semicolon. Now, before we finish up program for the day, we're going to make sure we put in at disabled at the top of our code. Then we're also going to go ahead and open up GitHub Desktop. We can go ahead and give it a title of Create Gamepad Practice, and our description can be tutorials for working with the Gamepad. We'll go ahead and commit this to our master, and then push it to Origin so that it saves up on GitHub Desktop. So I hope you found that helpful as a brief introduction into using mathematics for variables, as well as playing around with your Gamepad. We did a little bit of a 2 action there, getting your Gamepad up and setting. It's a lot simpler than you would think to be able to read those things inside of your Gamepad. If something didn't work out for you, got any more questions or need some more help, write down in the comments below, and I'll do my best to be able to help you out with that. Otherwise, best of luck on Program Your Robot, and best of luck out there this season.